Hello everyone, dear authors and invited guests, welcome to technical session 11D. I am Dimahi Patel and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, London, United Kingdom. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th February in London, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start with the session, I would like to introduce you all to the chair of the session. We have with us Professor Suresh Rasappan, sir. Professor Rasappan works as a lecturer in the Department of Mathematics at the University of Technology and Applied Sciences in Ibri, Oman. He is a distinguished academician and researcher with over a decade of experience in teaching, research, and administration. He has over 100 publications in reputable journals indexed in Scopus and Web of Science. I welcome you, sir, to the session, and I request you to share a few words that you may have for the presenters here.
Thank you, ma'am, and thank you for giving a wonderful, warm welcoming address. So really, I am always thanking for the ICICT 2025, the International Congress on Computing, Information and Technology. So morning also I attended. So really, it is if those who want to enrich their knowledge, it is a one good platform. So really, that I am impressed because from not only from India, so some content in France and some content in Canada and South Africa all are presented and shared their knowledge. I hope that this presentation also so giving a wonderful knowledge to all. I am welcoming you all and I am wishing you all the best for your presentation. Thank you. Thank you once again, Dimati Patel ma'am. Thank you.
Thank you, sir. Now we also have with us Dr. Nilesh Popat Sable as our session chair. Dr. Nilesh has overall 15 years of academic experience and is presently working as SPPU approved Associate Professor in the Department of Information Technology, Vishwakarma Institute of Information Technology, Pune, India. He has published over 50 papers in national and international conferences and journals, and he has also filed and published 14 patents and 3 copyrights. Moreover, he is the author of a couple of books with international publishers like Lambert. I welcome you, sir, to the session, and I request you to share a few words to everyone.
Yeah, thank you for the brief introduction. Looking forward for the research presentations which the authors will be presenting. Keen to listen them since morning. We are having wonderful sessions conducted by the event ICICT 2025. This is the third time I'm chairing the sessions of ICICT. From the 7th version, I'm associated with this conference and looking forward for it. So thank you and all the best to all the presenters over here. Thank you.
Thank you, sir. Now we will begin with the presentations. Coming first up is Mohammad Sufyan Akbar. I request you, sir, to present your research on advancing point cloud classification with deep learning by optimizing point net through transformations for superior accuracy. Mohammad, sir, are you present?
Dimai, please move for the next one.
All right. Next up is Salima Saeed. Salima, ma'am.
Yes, I'm here.
Yes, ma'am. Please begin your presentation on enhancing ovarian tumor diagnosis through transfer learning and convolutional neural networks.
How can I share my slide, please?
Yes, ma'am. Give me a minute. Please try to share your screen now.
Hi, everybody. My name is Salma Saeed. I'm a postgraduate student at Libyan Academy. I'm honored to present our research enhancing ovarian tumor diagnosis through transfer learning in convolutional neural network. We will start with the introduction, problem statement, and proposed solution, a quick look on lecture review, the methodology we worked through, beginning by data argumentation and techniques to the model implementations. Then we have the experimental results, model accuracy, impact of class imbalance, finishing with the conclusion and future work. Ovarian cancer is the fifth leading cause of cancer-related deaths in women. One of the main challenges in diagnosing ovarian cancer is the absence of clear early symptoms and no effective screening methods. Moreover, imaging results often vary because they depend heavily on the interpretations of doctors. Common imaging techniques include MRI, CT scans, and ultrasound. Ultrasound is preferred as it is non-invasive, but its accuracy depends greatly on the operator's skill. The goal of this research is to create an automated tool that can classify tumors accurately and consistently, reducing reliance on human interpretation. Current diagnostic methods have several limitations. Imaging results can vary from one doctor to another, leading to inconsistent diagnosis. There is also a risk of both over-treating and under-treating patients, which affects the outcomes. Additionally, these methods are not very effective in detecting early stage or borderline ovarian tumors, making early interventions challenging. To address these challenges, we proposed using transfer learning and CNN to improve diagnostic accuracy. The approach aims to reduce reliance on the operator's skills, provide more consistent results, and make clinical workflows more efficient. In our lecture review, we examined several studies. Leo developed a predictive model with Inception V3, an accuracy of 84, though the study was retracted due to the validation issues. Silvestra achieved an accuracy of 92 using VGG16 for ovarian CSET classification. Keely Carslin used hybrid CNN SVM with feature selection, achieving an accuracy of 98. Weo improved accuracy from 72 to improved classification accuracy from 72 to 78 using AlexNet with data argumentation. And Vasafi explored an advanced algorithm for CSET detection and classification, offering an early and precise treatment options. These studies highlight the potential of CNN in medical imaging, identifying areas for improvement, which guided our approach. For this study, we used the multimodality ovarian tumor ultrasound dataset, which contains 1,469 annotated images. It is categorized into 8 classes, 2 malignant, 5 benign, and 1 representing normal ovaries. Here is the class distribution. We can notice the variation in number of images between classes. As an example, number 1 class, chocolate CSET, which is a benign tumor, it includes 336 images, while number 6, theca cell tumor, which is a malignant tumor, has only 53 images. To address the class imbalance and reduce the overfitting, we applied data argumentation techniques. In our first experiment, the technique we applied were horizontal flipping, rotation, and brightness adjustment. This expanded the dataset to 3,518 images. We named it as Data 1. In the second experiment, we applied rotations at 12 angles from 0 to 330 and 30-degree increments. This increased the dataset to 17,628 images. We named it as Data 2. The techniques we used for transfer learning, the pre-trained CNN, were YOLO version 8 Nano, VGG 16 as a feature extraction and fine-tuning. We had modified VGG in layers for optimizing classification. The YOLO model trained from scratch and with the pre-trained weights. And the VGG 16 was the baseline and the modified. In our study, we have two phases. In phase 1, we used Data 1, the YOLO model trained from scratch with 17, 20, 10 train validation test split with a batch size of 32, 100 ebook, and learning rate of 0.001. The VGG 16 model trained as a feature extraction and fine-tuned for the last 6 layers. In the second phase, we used Data 2. We implemented a modified VGG architecture with 9 confusion layers, max pooling, activations, batch normalizations, dropout, and dense. The output was 8 units. The training setup includes 70, 20, 10 train validation test split. The batch size was 64, 150 ebooks, and the same learning rate. We used accuracy, precision, and recall to evaluate our model. Accuracy shows overall correctness. Precision measures correct positive predictions. And recall checks how well the model identify positives. These two tables shows the model's accuracy for both phases. In phase 1, the accuracy increased from 50 to 74, while the training time decreased from over 90 hours to around 36 hours, moving between YOLO scratch, YOLO pre-trained, VGG feature extraction, and VGG fine-tuning. These results directed us to phase 2, where we used Data 2, which includes more number of images to let the model learn better. We chose the VGG due to the accuracy results we obtained from phase 1. We made modifications in the layers, and the result shows that the modified VGG achieves the highest accuracy of 19% with much short training time of just 8.63 hours. These tables clears the impact of class imbalance on model performance. We can observe in table 1, phase 1, that the class imbalance has a big impact on recall, especially in malignant tumors. As an example, number 8 theca cell tumor, the recall on YOLO scratch was 33, improved to 52 in the pre-trained YOLO. In phase 2, the modified VGG handled it much better, where the recall reached 90. This highlights the effectiveness of the modified model. In conclusion, our study demonstrates that the modified VGG is outperform other models in classifying ovarian tumor. Highlight the effectiveness of customized CNN and medical imaging tasks for future and For future work, we plan to use larger data sets to improve model generalization, test the model in real-time diagnostic tools for clinical applications, combine CNN with other models to enhance the performance. Thank you for your attention. Please feel free to ask any question.
So nice.
Participant, anybody have any doubt? Please, it is now your time. Okay, Salma, I have some questions. Actually, you are presented well, and you are presented a good research work also. So over cancer diagnosis by using a deep learning method. So I have some few questions. So it is your own data set, or previously anybody used data set?
I can't hear you. Can you
Actually,
repeat the question? The data set what?
It's your own data set or already existing data set?
Yeah, am I audible? Yeah, I'm present now.
Yes, sir. Mohammed Akbar, please present your study on advancing point cloud classification with deep learning by optimizing point net through transformations for superior accuracy.
So, good afternoon, everyone. My name is Mohammed Sufyan Akbar, and today I'm here to present our topic, Advancing Point Cloud Classification with Deep Learning by Optimizing PointNet through Transformation for Superior Accuracy. It is a collaborative work with Goji Andong, Mohammed Irfan Khan, Asif Iqbal, and Salim. I'm currently studying in China, University of Electronic Science and Technology of China. So the content of today's presentation include abstract, introduction, related work, methodology, result and discussion, and then comparison with existing studies, conclusion, and then future work. So our paper presents optimized PointNet for 3D point cloud classification, enhanced spatial feature extraction, and improved robustness to noisy and sparse point cloud data, which help us to achieve the higher accuracy of 92%, which is higher than compared to our base model. We actually use the effective data pre-processing pipeline, which uses normalization, downsampling, and augmentation techniques, and extensive evaluation on benchmark datasets for real-world validation. Our abstract presents a deep learning approach for 3D point cloud classification, which actually we optimize the PointNet, which is introduced in 2017, is a basic model for 3D point cloud classification. We optimize it, and now it's effectively handle the unordered point cloud data and help us achieve the accuracy of 92%, precision and recall of 91%, 89% of F1 score, and 96% of sensitivity and specificity. And we actually use the benchmark datasets for the object recognition. Introduction. A 3D point cloud is actually a collection of data points space which represents the object surfaces. And it's really useful in autonomous driving, robotics, medical imaging, augmented reality, and virtual reality. And classification of point cloud is really important for object detection and scene understanding. The real challenges in ordered point cloud is that they don't have any fixed structure, and it really requires a high computational cost to process the large point cloud datasets, and noise and occlusion always affect the accuracy. So the motivation behind this work was to introduce an efficient and accurate classification model. And PointNet directly, as we know, PointNet directly processes the raw point cloud data. So we want to introduce a pre-processing pipeline which help us PointNet to first pre-process it and then pass it through the PointNet. Here is the related work. PointCNN, which uses convolutional neural network and help us achieve the 90.3% accuracy on ModelNet 40, which is a benchmark dataset introduced by Princeton University. But it introduced some computational overhead for transformation processes. And graph-based model, which was introduced in 2019, it uses graph neural network and help us achieve 89.1% accuracy on ModelNet 40. But there were some scalability issues. And attention-based mechanism, they use some attention-based models, and they also achieve accuracy equals to the PointCNN, but they were very sensitive to noise occlusion. And point cloud CNN, they were actually hybrid models, use PointNet plus convolutional neural network, but their accuracy was not as good as point CNN and attention-based mechanisms. And the PointNet will add, they uses vector quantized latent variable modeling, and they achieve 71% of recall on Oxford robot car dataset, which is different than others. Now, next one, what was the gaps which we are working on? Many models struggle with the large scale datasets, affecting scalability. Handling noise and occlusion is always remain a challenge in real world applications. And current methods still need better feature extraction for complex 3D structures. And computational efficiency is definitely a concern for real-time applications. And models often require large label datasets, which are definitely difficult to obtain. And generalization of different domains is limited, reducing the practical adaptability. Here is the methodology framework of our model. We use a database which have the point cloud data. We first pass it through the pre-processing pipeline, which uses point cloud normalization, downsampling, noise removal, and augmentation to make our data more robust. And then we pass it through the PointNet model architecture, which includes input layer, feature extraction, classification layer, and symmetry function. And for model training, we use these specification. We use our Adam optimizer, batch size of 32, 100 epochs, and learning rate of 0.003. And we also use a dropout layer. And for model evaluation, we use accuracy, precision, recall, F1 score, and confusion metrics as the matrices to help us evaluate the results. And we use data which is already mentioned, the ModelNet 40, which is from Princeton University, and it contains 3D objects, including the categories like chairs, tables, airplanes, cars, and etc. And each of the object represented as a set of unordered 3D point cloud, which is represented in X, Y, and Z coordinates. So here is a summary of our data set. And the data pre-processing pipeline, first of all, we have this 3D meshes of point cloud data. First, we pass it through the point cloud normalization to make it simple, and the whole data will be turned into 0 to 1 form. It will be in 0 and 1, could be 0.5, 0.3, and something. And then to make it downsampling, we use voxelize technique to reduce the number of points per object. And then for noise removal, we set a threshold which help us to eliminate the points which are not necessary to be obtained to be included in our processing. And then to make our data more robust, we use the augmentation technique, which include rotation, flipping, and scaling of the point clouds. And later on, we got the pre-processed point cloud. Now that pre-processed point cloud will be passed through the PointNet architecture through 3 neuron layers. Input transform, they use the TNet architecture to use this augmentation technique. And then this augmented data will be passed through a 64 by 64 block, multi-layer perceptron block, which uses the shared memory. And for feature extraction, we again uses a 64 neuron layer feature extractor. And then we pass it through 1024 block, which also uses a shared memory. And in order to obtain the global features from here, we use the max pool function. And by using gravity function, at the end we got a fully connected layer to classify our objects. And here is the classification. Methodology model architecture, for more detail, we will explain here. The first input transformation network we use is our T.P. Here T represent the learned metrics from the network. And for feature extraction network with shared multi-layer perceptron, here we used to extract the features from point cloud data. And in order to obtain the global features, we use max pooling function. And this output classification network, by using additional multi-layer perceptron, we use softmax function to finally classify our objects. And in order to calculate the loss with cross entropy, we use this function. And for network optimization, we use this formula to optimize our network. We call it Adam optimizer. And then we will go to the output matrix. Here we can see our model training results. You can see that how on increasing the number of epochs, finally we are getting better results. And at the end, we are getting 92% of accuracy. And training and validation losses were completely reducing as we increase the number of epochs. We use accuracy, precision, recall, F1 score, specificity, and confusion matrix as our evaluation matrices for results. And confusion matrices shows the classification performance across different classes. High diagonal values indicate the strong classification ability, and only minimal misclassification across all selected categories, which shows the good results of our model. These are actually the results of our pre-processing. So here we can see first this is the original point cloud. First we normalize it, and then we downsampled it, then denoised, and then augmented. Augmented uses a few techniques: flipping, rotating, and scaling. And here are the results of our model. We use accuracy, we got 92%, precision 91%, recall 91%, F1 score of 89%, and sensitivity and specificity of 96%. Here is the confusion matrix for our model. Here we can see that for class 0, we got 99 accurately predicted, but one was misclassified as class 1. And for class 1, we got 94 predicted as the true positive, and 2 were predicted as class 4. And same for all. All of these are actually true positive, or we can say accurately predicted. These are the model predictions at the end of our model. And here are the comparison with existing studies. We can see that our point-net model proposed was actually beat all of state-of-the-art models, and we got accuracy of 92%, F1 scores of 89%, sensitivity and specificity of 96%. So conclusion, the point-net model achieved 92% accuracy, demonstrating the strong performance in 3D point cloud classification. High precision 91%, recall 91%, and F1 score of 89% indicate our model's reliability. The model efficiently handled the unordered point cloud data with minimal pre-processing, which is one of the achievements. The confusion matrix shows a low misclassification rate, proving robustness of our model. And key point, PointNet is an effective and efficient deep learning approach for 3D point cloud classification. Despite its strength, there is a room for improvement, particularly in handling the complex structures and noisy data. So our future work will include improving the feature extraction techniques for better geometric understanding, experiments with hybrid model, for example, combining the PointNet with graph neural network, explore self-supervised learning to reduce the dependency on labeled data, which is required. Scalability and real-world application optimizes the model for large-scale dataset and real-time inference. Develop techniques to handle occlusion and noise more effectively. Apply the model in real-world scenarios like autonomous driving, medical imaging, and robotics. These are some references, and thank you so much for listening. If there is any question, you're welcome to ask.
Audience, any doubt? It is now your time. If you have any questions, please ask. Safi, I have one question. Actually, what do you exactly meaning the superior accuracy?
Superior accuracy, which actually means that we are beating the previous state-of-the-art models here. Actually, we are transforming the original point-net architecture, and on the basis of that, we are introducing some pre-processing steps, and we are getting better results.
Okay, so here already the graph network is existing. So what you are going to implement by using the graph network? But already the existing work exists in graph network for identifying 3D or architecture or 3D image. What are the things which available graph networks? Even though even though your work architecture is completely then the CNN architecture. So there is no any augmentation or what other things not available. So how you are going to claim it is novelty?
Are you talking? Let me make it clear. So your question is how we can use GNN for future work, right?
Yes, actually, so it is your model is based on the CNN architecture network. So there is a so how you are claiming it's your work is novelty and
We
superior
are
accuracy.
we are actually introducing some minimal pre-processing steps, and we are reducing so much work which will be done by PointNet original architecture. We are trying to play with the transformation layers, and we actually introduced transformation layers as well in the model. And some of the layers are actually stopped because we are using some pre-processing steps.
Okay.
Yeah.
Thank you.
Nilesh sir, do you have any questions for him?
Yes,
Doctor.
yes, yes, yes. Uh, the data set which you have used, it is same for all the what we can say prerequisite which you have stated there for comparative.
Yeah, actually, ModelNet 40 is a benchmark and standard data set which is introduced by Princeton University, and most of the techniques they are using this data for 3D object classification. So the things introduced here, most of these studies, all of these existing studies, they use this ModelNet 40 data set.
Okay, so it is for the similar data set which you have. Okay, fine, fine. Thank you.
Yeah, yeah, no problem.
Okay, thank you sir for your presentation.
Thank you so much.
I would like to call Timothy again. Timothy sir, are you present with us?
Yes, I am.
Yes, sir. Can you please start with a presentation on data-driven analysis of women unemployment in sub-Saharan Africa, a multiple correspondence approach for promoting sustainable development goal?
All right, thank you. Good afternoon, everyone. My name is Timothy Adeli. This study was done with other of my colleagues, Fumi Adebeshe and Edian Gumo. The title is Data-Driven Analysis of Women Unemployment in Sub-Saharan Africa, a multiple corresponding approach for promoting sustainable development goal. I will start with my introduction, move to research gap, related works, methodology, results, and some discussions, and I will then conclude. We've seen that in sub-Saharan Africa, which is a diverse region, employment conditions really differ significantly between the urban area and the rural area. Women still face obstacles in integrating productive sectors or getting a well-paid job. It is most important to note that in sub-Saharan Africa, they have made effort to address gender disparities in the labor force through policies promoting gender equality and female empowerment. However, challenges such as limited access to education, finance skills, training, marital status, or political instability, and gender-based discrimination in the labor market persists. Hence, about 90%, based on literature, about 90% of women in sub-Saharan Africa are employed in the informal economic sector, making unemployment rate among women to continue, which is concerning in major countries in the region. And this leads us to study aim to provide a valuable insight for policymakers, stakeholders, and development practitioners on the key areas that need attention to reduce this gender gap in terms of employment. And I'll focus a little bit on the research gap. In my research gap, it's despite numerous studies on unemployment and gender disparities, especially concerning women in the labor market, there remains a limited focus on specific socioeconomic and demographic factors influencing women employment in sub-Saharan Africa. In fact, existing research often generalizes unemployment trends without a granular data-driven approach that looks at multi-dimensional barriers that is unique to women in this region. In fact, if we look at the Sustainable Development Goal, it underscores gender equality. In fact, there is also a lack of empirical studies leveraging the multiple corresponding analysis to systematically map out employment disparities and their interconnection. Taking me to my related works. In fact, the United Nations Sustainable Development Goal, that's the SDG 5, they seek to achieve gender equality and empower all women and girls by 2023. However, this was impossible. And I would say it wasn't achieved anyway, because in 2024 report, you can see that women and youth continue to bear the brunt of high level of unemployment compared to male adults in most regions of the world. And there are a lot of reasons has been profiled for this high level of unemployment, which includes probably exclusion from quality of education, gender role that confined women to unpaid domestic work, the lack of policies, inadequate enforcement of policies to protect women from unfair labor practices, and digital divide. So in my materials and method, we got a data set by the National Population Commission conducted in 2018. It was collected between August 14 to December 29, 2018. It consists of about 41,821 inputs of women aged between 15 to 49. And for this analysis, we have 13 features. However, for a pre-processing, we chose to use 12 potential features, which includes region, type of place of residence of the women, age, educational level, ethnicity, religion, household, head, gender, wealth index, their marital status, age of responding at first birth, if they are currently pregnant or their pregnancy time. So these are features that we use in our analysis. Then by employing a data-driven approach, we then use the MCA, the multiple corresponding analysis, to uncover complex relationship between the socioeconomic, cultural, and demographic variables influencing women employment status. This method enables a comprehensive understanding of multidimensional nature of unemployment. Data were analyzed using a multi-CAD toolbox in MATLAB, taking advantage of the simplicity of MCA implementation provided by this tool. And in my result, this is a script plot of the eigenvalue versus number of dimensions. We were able to have 23 dimensions. We can see that the first dimension has the highest eigenvalue, approximately 0.81. The second dimension, the third dimension down there. But something we can realize is that from the fifth dimension onward, the elbow of the script plot tends to level off, contributing to the drop of eigenvalue. Hence, the 1 to 5 dimensions were used to do dimension reduction in order to choose the number of factors to analyze. And in our result, we can see that through this MCA biplot, it visualizes how socioeconomic status such as the wealth index, geographic region, and age are interconnected, and how they correlate with unemployment among women in sub-Saharan Africa. And if you look at, you can say richer, poorer, and with saying richer and richest are located in the upper left quadrant, which indicates that they are associated with each other. And you can see poorer and poorest are located in the upper right quadrant, suggesting a different grouping. Meaning wealthier categories are further from categories related to low wealth, indicating distinct socioeconomic group. In terms of women and unemployment, it means that women in the richer and richest categories are likely less affected by unemployment due to better access to resources and opportunities. Conversely, those in the poorer and poorest categories may face high unemployment due to limited opportunities that is available to them. And when we look at different regions, such as the North Central, Southwest, Southeast, Northeast, and Northwest, they are spread across the plot. This distribution indicates a regional difference in socioeconomic and demographic factor. For example, we can see South, South, and Northeast are relatively close to the poorer wealth category, indicating a potential regional correlation with lower wealth level. So with regards to women unemployment, regions like the Northeast, North Central are associated with poorer wealth indexes, which may experience higher unemployment rates among women. And we can see the age category between 15 to 19, 20 to 24, 25 to 29 are spread out as well, with younger age around 15 to 24 located near wealth indices related to lower wealth, which is poor and poorest. And we can look at the older age group. They are more dispersed, showing varied association with other factors. And we can see that older women might have more stable employment due to accumulated experience and resources as suggested by their spread across various wealth categories. So in conclusion, Unemployment remains a significant challenge in both developed and developing countries, leading to underutilized resources. However, in sub-Saharan Africa, high unemployment rates are heightened by weak economic indicators. We've made use of MCA, and the research identifies critical factors such as the age, region, wealth index that are significantly correlated with higher unemployment rate among women. And we have these suggestions. We have about 4 of them to say, in order to promote this equity in economic opportunities through targeted support for women in low-income categories. Secondly, we look at how can we enhance access to quality education for women in high unemployment regions, particularly young and less educated individuals. Thirdly, is designing region-specific programs that addresses unique socioeconomic and cultural context. And lastly, to tackle systemic barriers like discrimination, cultural biases, to boost women participation in the workforce. And that is the end of my presentation. And thank you so much.
Sir, do you have any questions for him?
Actually, I have that. What do you mean that eigenvalues representation in that graph you showed? Actually, what is the role of eigenvalues here?
So the eigenvalue helps us to identify, put all those factors into different dimensions. And the eigenvalue is what we use to know which dimension is most relevant. Dimension 1 has the highest eigenvalue, and factors that is involved that is attributed to dimension 1 they have much more positive correlation than other dimensions. So the eigenvalue helps us to perform dimension reduction based on the script plot. Thank you.
Okay, thank you.
Dr. Nilesh, do you have any questions for him?
Have you designed any sort of questionnaires, and what parameters you have considered while designing that questionnaires for taking and relevant feedback from women?
So we weren't the one that took the data. It's a public available data set that looked at women who are currently unemployed. They look at different factors that could cause them to be unemployed. So they look at their
For
socioeconomic
for
status.
for justification of that currently available data set, have you taken
Yeah,
any limited sort of what we can say live feedback by designing some sort of questionnaires?
the data set is publicly available. However, because we are not the primary owner of the data set, we can not really give a feedback onto the data. But one thing we've done is that based on these studies, we are trying to reach out to those that collected data set to tell them about the analysis that we've been able to make based on the data set.
Yes, you can have your own analysis that by designing some questionnaires, and then you can correlate with the data set which you are currently using, right?
Yes. It was correlated already, and that's what we did in our MCA to look at the hidden association that when you do normal statistics, there's some relationship you can see, and based on the MCA, we are able to find some hidden relationships that weren't considered during the normal statistics that was taken in the data set.
Okay, fine. Thank you. Thank you.
Thank you so much.
Thank you, Timothy, for your presentation.
Thank you.
Laksha Agarwal, are you there with me?
Yeah, am I audible?
Yes, sir. Please present your study on remote voting system using biometric authentication.
First of all, good evening, everyone. I'm Lakshya Agrawal, and I'm delighted to present our research on remote voting system using biometric authentication with my co-authors, Dr. D.S. Adane, Shraddha Vangota, and Sharvari Namdar from Sri Ramdev Baba College of Engineering and Management, Ramdev Baba University, Nagpur. The primary goal of this study is to address the limitation of India's current electoral system by proposing a biometric authenticated voting system ensuring secure and inclusive elections. So to dive into the background of the study, India, as the world's largest democracy, has continuously evolved in its election process. However, a significant challenge still remains, ensuring participation of remote workers and internal migrants who numbered around 600 million in 2020. Due to the inability to vote outside of their home constituencies, voter turnout suffers, impacting democratic representation. To solve this, we propose a biometric authenticated cloud-based system, cloud-based right now, but as soon as it is implemented by the Election Commission of India, it will be developed by their in-house servers, which will further be managed by the internet already present in government institutions. So to solve this, we propose a biometric authenticated cloud-based remote voting system that allows voter to cast their ballots or votes securely, no matter where they are. This ensures that every eligible candidate can participate, reinforcing the principles of inclusivity and transparency in India's electoral system. So, developing a secure, scalable, remote voting system authentication using biometric authentication. The objective of the study was to develop a secure and scalable remote voting system that authenticates users using biometric authentication, ensures accessibility to remote voters through a seamless mobile-based platform right now, but in the further iterations, we are trying to move into a Raspberry Pi so that the device cost could be brought down to conduct election in such a big country like India.
Excuse me, sir. I'm sorry for
Yeah.
interruption, but we can only see your starting page of the presentation.
Uh,
Are you changing your slides?
yeah, are you able to see the slide now?
No, sir, we could only see your title screen.
Is it visible now?
Yes, sir, the literature review page is visible to us
Yeah,
now.
okay. I'm on that page only. So before diving into what we did, let's see what were the systems developed for voting earlier. First of all was the first past the vote system. Is the screen visible actually right now?
Yes, sir, yes, sir.
Yeah, okay. While simple and efficient, it often led to disproportional representation and tactical voting. Ballot paper voting, which is currently used in many countries right now, a traditional method that ensures security but is slow, prone to fraud, and environmentally unsustainable. Now, the machine or the mechanism which India uses currently, which is the electronic voting systems or electronic voting machine. This improves speed, reduces errors, but has security concerns and infrastructure dependencies, which we prone to reduce. And the final and which have developed is a biometric enabled voting system, which uses a fingerprint authentication right now. We would further move into iris scanning and face recognition also. The advantages are many. First of all, the remote voting would be possible through it, and it prevents fraud, eliminates booth capturing, duplicate voting, and it ensures overall security and accuracy of Indian elections. The challenges which we are trying to overcome are the cost, legal compliance, and the failures of technology which can happen during the implementation of the system. So yeah, this is the system design and architecture. This figure demonstrates the ERD maps of how voter data is structured, stored, and retrieved all around our app. Second is the data flow diagram shows how information moves within the system from voter registration to ballot submission. As you can see, we have made 5 tables. The vote collection is separate from all the tables to ensure security for storing vote and declaring the results. And moving on to the data flow diagram, you can see the whole data flow through which the user data is encrypted and stored and verified. So yeah, moving further, a bit explanation of how we implemented the architecture. Our system is built with robust architecture focusing on security and real-time data processing. First of all, we use the Google's Firestore database, It's a cloud-based storage solution with real-time updates, which helped us to maintain and make a very fast, quick, and reliable database for our needs. Second is the biometric registration. We use the Mantra MFS 100 SDK or the Mantra MFS 100 fingerprint scanner, which is used by most of the government organization and banks and considered to be the most secure fingerprint authentication device available for commercial usage. Voter authentication is done by the fingerprint scanner, and the election management interface is between the Election Commission of India. They manage election, register candidates, and monitor voting via Node.js based admin panel. For the data security and encryption, we have used HTTPS protocol to ensure data protection, and the fingerprints data of the users also remain private. So this is a short video on how the app works. First of all, it's a simple voter registration app in which the users can enter their voter ID, name, mail, and the constituency code from which they belong. This can be found in the voter ID present in India, and their fingerprint is captured and saved to the database. Moving further comes the candidate registration part for a particular constituency. The candidate data form, in which we can simply see for the demonstration purposes that we enter the constituency code for the constituency from which the candidate wants to represent the candidate's party. Here we have taken John Doe and Johnny Doe from party A and party B. Further, moving on to the election data form, in which we schedule the election. By entering the constituency ID, we fetch the candidates and we can add them to the election and schedule an election with just few clicks. After submit election, the election would be scheduled successfully. Moving on to the important part, which is the voting, in which we developed another app in which you can enter the voter ID or scan your voter ID, which is provided by the Indian government, and match your fingerprints and move on with the voting screen. In the voting screen, nothing is visible except the election ID, which is also the encryption key. And after voting, you cannot vote for other person, ensuring no duplicate votes are given. And after the voting is done, it's time for the result. Entering the encryption key to fetch results, which would be only available to the Election Commission of India, we can see we have successfully conducted our election. So yeah. Moving further, what we did was to validate our system. We conducted an in-class election for the class representative. We set up our registration and voting booth, mimicking a real-world remote voting scenario. Voters registered using fingerprint authentication, ensuring a fraud-proof process. We recorded the entire process for evaluation, and photographs documents the successful execution of our prototype. The current CR of our class 1, of course, he is the CR and was elected democratically previously too. So yeah, this was a fair election. Now moving on to the results in conclusion. For now, the accomplishment we have is the fingerprint scanner is the fingerprint accuracy, the accuracy of our fingerprint scanner is very high, being at 98.7%. The data processing is fast right now, and we currently use the public network or the internet for the data travel, which can be a cause of hacking or misinterpretation of the system, which would be solved by the government when implemented by the Election Commission of India. Our future plan is to upgrade the infrastructure to support the national elections and state elections. Right now, we have constituency data which is publicly available for state election, and we are planning to make a smaller device which can ensure security and offline access to the voting system. Impact on the election. Impact on Indian election would be, it would boost the turnout dramatically, it will eliminate election fraud, and it will enhance transparency, and it will be faster and cost effective. So that's it from now. That's it from my side. Thank you so much from Sri Ramdeva College of Engineering and Management.
Suresh sir, do you have any questions for him?
I have so few concerns. The first one is security risk. So whatever the things we are encrypting, now we have the more and high sophisticated hackers. So the cases, what about your model is working? So one concern. So second one,
Nilesh sir, do you have any questions for him till then?
No,
I'm
no
getting
question.
getting my voice now.
Yes, yes, Suresh sir, you can go ahead.
Yes, sir.
Actually, my one question for large scale data, how you are going to manage?
Uh, the implementation currently can handle a large scale database, but our implementation could not work for the Indian government or any kind of government because this is owned by Google. Google owns the database, which is not recommended for conducting an democratic election for a country. So the whole database would be managed and created by the Election Commission of India for the managing of the election.
Yeah. Okay, thank you.
Thank you, sir. Thank you so much, everyone.
Thank you, Lakshmi, for your presentation.
Thank you.
Now, next, I would like to call Khalaf El-Wadia to present his study on user data privacy on social media, policies, practices, and perceptions. I believe there was some technical error. I would request everyone to wait for 2 minutes.
Okay, I will share my screen now.
Yes, sir, your screen is visible to us.
Okay, perfect. Okay, so my name is Khalaf El-Wadia, and I'm going to be discussing social media privacy policies, user awareness, and preferences. And this research is going to explore how platforms handle user data and how well users actually understand their own privacy settings. So first, we're going to go over a quick introduction. I'm going to go over some related works. I'm going to go through the methodology of our study, then the results of that study, and then analysis of the results, and then a quick conclusion at the end. So overall, social media platforms collect huge amounts of personal data, and that spans from just regular preferences, and it goes all the way over to very sensitive information. Privacy policies play a critical role in governing how that data is stored, used, and shared. However, many users don't actually fully understand these policies, which leads to concern about data security. So some previous studies highlighted issues like transparency of privacy policies and the gaps in understanding of the users, as well as concerns over data monetization that social medias have. One study found that many users struggle to understand their own privacy controls, so they don't actually have the awareness of how to make those changes within their account. And then Nicholas et al. Explored how companies monetize user data, and they often do so without clear user consent. So the methodology for our study was that we conducted a comparative analysis of privacy policies across some of the major platforms that included TikTok, Instagram, Facebook, as well as now X, or formerly Twitter. We also surveyed users to assess their awareness of their own privacy settings, as well as their concerns about data security in certain social medias. And we focused on mainly the storage of the data, user trust, as well as the balance between privacy and user convenience. So the results of our privacy policy comparison was that platforms often differ in their account verification process, and this can affect their security as well as their privacy. And social media apps store user information, like some very sensitive user information, including some browsing history, location data, as well as device information about the device that's using the actual app of the social media. Most platforms share their user data with advertisers and other third-party companies, and in some cases, even foreign governments. And privacy laws often vary hugely by region. So in Europe, there's much stricter enforcement under the GDPR laws. And many users find that privacy policies are very hard to understand, or they simply just don't read them. So the demographics of our survey was mostly participants aged 18 to 28, predominantly university students, and Instagram was the most used platform, followed by TikTok after that. So with regards to the usage, TikTok, Instagram, WhatsApp, and were the most used platforms, with fewer of them using Twitter or Facebook. And this kind of aligns with the industry trend of showing that younger users typically prefer more visual-driven platforms. So with regards to the user's concern, users were most concerned about TikTok's data handling, with Instagram being second despite its high levels of usage among this group. Pretty unsurprisingly, over 90% of the users we surveyed did not read their privacy policies when signing up for these social media accounts. 84% of them, however, were at least partially aware of their own privacy settings, but very few of them made adjustments to those settings. So this suggests that perhaps there needs to be a better education on the privacy settings and what the user actually has control of in their account. When we asked about the trust that the users had in the social media companies, most users said that they had concerns about the data that was being collected about them by social media companies. And they said that privacy was important to them. And most users just simply did not trust social media companies or governments to protect their data. Despite this, they continued to use these platforms, showing that there was a disconnect between their concern and action that they were going to take. So it's pretty transparent that Meta, Google, and TikTok have all been fined for violating user privacy. Particularly TikTok in recent months has been kind of under the spotlight for concerns about user data. However, users care about their privacy, but they're kind of refusing to take action. This could be the way that social medias are designed to be like addictive, and it makes it so that it's much more difficult for users to take action with regards to their privacy. Most users also rarely adjusted their own settings within the apps themselves. So this shows that they either weren't aware of the actions that they can take with their own settings, or they simply just were concerned, but not concerned enough to actually take action to change those settings. Users were particularly wary of TikTok due to its recent news about its recent data sharing practices, particularly with a foreign government. And despite Instagram being linked to very frequent privacy violations, it remained as the most widely used social media platform. One potential solution is that simply privacy policies have to be simpler to make it easier for users to understand what they're signing up for when they make these accounts. Also, the fines for violating privacy laws for the social media companies needs to increase, because under current systems, it's still seen as a net profitable endeavor for these social media companies to violate these privacy laws in order to sell data so that they can get profit from that through advertising. So kind of in conclusion, users expect privacy, but continue using the platforms that exploit their data. And companies prioritize data collection despite the awareness that there is growing concern among their users about this data collection. Users seem to distrust platforms, but remain highly engaged in those platforms due to just the design of social media and the kind of addictive nature now with kind of these infinite scrolling platforms. And there's a need for much stronger regulations globally. GDPR is perceived as the most effective. It's perceived as more effective than North American laws. So that highlights the need for better enforcement, because there have been fewer violations of privacy laws in Europe under GDPR than there have been in other areas of the world. And a simple call for transparency, where social media companies need to make their privacy policies clearer, more user-friendly, so that it's simpler for users who are creating these accounts to understand what exactly they are signing up for when making these accounts. Thank you all for taking the time to listen. I'm happy to take any questions.
How you ensure the data individual privacy sectors in social media platforms?
I'm sorry, say again?
Sir, actually, that in social media platform,
Yeah.
in your research, you are mentioned about the risk factor of privacy. So,
Yes.
in how you are ensure the privacy is more concern in your research area?
So one way to do that is through more government regulations, where governments would fine these social media companies more for violating these privacy laws to the point where it would no longer be profitable for them to sell that data to advertisers. And if that becomes the case, then these privacy regulations would be much more effective. Also, just simple calls for more transparency of these social media companies where if they're going to be sharing data with some third parties, they should be more upfront or more transparent about that before they do so.
Okay. Thank you.
Nilesh sir, do you have any questions for him? Okay, I believe there are no more questions. Thank you, Khalaf.
Thank you.
Now, before we reach the closing ceremony, I would like to give one last call to Mohammad Anwar Rahman. Mohammad Rahman sir, if you're present, please let us know. Or if there any co-author present, please let us know right now. Okay, all right. We'll move to the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. I would request everyone to cooperate with the team of ICICT 2026 and 2025. And before we end, I would like to thank Professor Suresh Rasappan sir for chairing this session, extending a token of appreciation on behalf of ICICT 25 and Global Knowledge Research Foundation and partners. Sir, I will request you to share any closing remarks you may have for us.
Really, thank you for giving this wonderful opportunity. So it is my first conference in the global research. So you really are welcoming more, and you are giving opportunity to grow my knowledge. So thank you. So definitely in future also I will be part of this global research conference and all the things. Thank you giving this wonderful opportunity, and presenters, that really you are in the right track. So you are all presented well. So I really impressed your works. I had some knowledge papers. The first the ma'am presented the convolutional neural network using over than point view about point net super accuracy, and Southern Africans employment that got filled the data. So Lakshay Agarwal, so all are presented well. So you are in our right track. So I am wishing you all the best for your successful future. We will meet on the next ICIST conference. Thank you for giving this wonderful opportunity.
Thank you, sir. And I would also like to thank Dr. Nilesh Sable sir for chairing this session. I'm sharing a token of gratitude for your valuable presence, sir. If you have any closing remark for us, you may please share.
Yes. Thank you. So it was really a great session and knowledge sharing by all the researchers present here. Wish you all the best for your future endeavors. Moreover, the suggestions given by the reviewer Suresh sir and myself, and the questions which were asked by audience and both the session chairs, you kindly consider it and see that you can make the advances in your further research. So thank you, Vandana.
Thank you so much, sir. Now, before we conclude this session, I have one last request for you all to switch on your cameras for a quick snapshot for the virtual conference. All right, thank you everyone. Have a great day ahead and take care.